Oops, hang on. In the last video I got to this point where I've built the model that Aaron wants to show, where he has himself, food sellers and everyone else involved in a monetary transaction economy. And I got it working, obviously. It's showing Aaron starting off with $100 or 100 million, whatever. And that runs down to about of the order of $44.9 in his account. Everybody else starts with 0, gets up to 48.7. The food seller starts with 0, gets up to $6.41, and then you have all these transactions taking place over time. So yeah, I'll leave that little. I'll go into this in more detail when I design another model. Part of the problem in this model is that what the hell do I mean by spending rate for Aaron here? What does 5 apply for Aaron? What happens when it's 1 in terms of spending on food, etc., etc.? Because I can run the model and I can change these, and you'll see it changes the system. Let's just run this and show it. So if I increase Aaron's spending rate, and notice the amount of money in his account goes down, but the amount he's spending goes up. And I can do the same for everybody else's accounts, but like I'm doing here, and so on, getting a high level of economic activity coming out of this by looking at it, but it's still hard to interpret. And what I've been taught by my good friend, the Norwegian systems engineer Trond Andresen, is that I should use time constants instead, and I now use that all the time. Now here's the Wikipedia definition of time constants, so let's just take a look at the first sentence there. It's a parameter characterizing the response of a step input of a first order linear time invariant system. Okay, well if you're an engineer that's obvious. If you're not an engineer, what the hell is that talking about? What I want to do in this video is rebuild this simple, effectively 3-sector model that Aaron wants to work on, and then show using time constants rather than these spend rate things over here, and show how it's actually easy to understand. And it's why I've got into the habit of using time constants in all my Minsky modeling. Anyway, I'll save this. Let's see. Using a lot of shortcuts. One thing we've done, courtesy of the Friends Provident Funding, is add some absolutely standard stuff that most other programs have, but Minsky didn't have because we were in such a rush with such a small amount of funding to add the fundamental features, the capacity to model dynamical systems and so on, that we left out the basic stuff people are used to, such as, for example, being able to use the control key of the letter A to save a file using a different file name. So I'm just going to use Control A to bring that up straight away, and I'll make that stage 2B. Also simple things like, for example, being able to grab several icons like this and drag them around at once. That wasn't possible before the Friends Provident Funding. Instead, you had to grab each item and move it individually, and that just took forever. So this is one of the things which doesn't look like much when you see it being done, because you think, oh, well, that's just like moving a couple of paragraphs of text in Word. But trust me, it takes a lot of programming time to get that done properly. So anyway, I'll just shut this version down. Minsky will warn me that I've made a change and not saved it, but that's cool. I'll just ignore that warning. Okay, and we start all over again. So the first thing is to create what we call a Godley table, give it a title, and I'll call this bank A, because I'm going to have make it possible to have several banks of this model later on. And then right-click and choose Open the Godley table, and make the scale a bit larger so you can see what's going on. Incidentally, just as a reminder, notice there is a plus and minus keys here below the asset column and the liability column. That's so you can add and delete and move entries around in the assets and liabilities. It's not there for equity because by default there is only one equity column, because equity is fundamentally a residual. But sometimes you might want to have more than one equity account, so you just go to options here and choose the enable multiple equity columns, which is the thing I thought was a bug in the first video, Aaron, that obviously was a feature. If I come across here, I've now got 3 equity columns, but I don't need them. I'll stick with just one, and I'll go back and turn that off so I don't have a chance to add additional equity columns. Okay, so the first thing I want to have is reserves, and I make this reserves underscore A so that I can bring in another bank, which might be bank B with its reserves being shown reserves underscore B. Then I have Aaron underscore D, because this is a deposit account. I could have another, I could have Aaron having cash as well, which would not show up on this table, it would show up on another, but that'll make it possible for me to do it. And I'll have the food sellers, and I'll have all others. And then finally, bank A, showing the equity of the bank. And probably the most important thing Minsky does is make sure that when you're building a model of a financial sector, everything is consistent. All flows go somewhere and end up somewhere, and also all initial conditions are consistent. So I have, say, $110 inside the reserve account, then I must have 110 total on liability and equity, so this row sums to 0. So I'll say that Aaron's got, say, 90 of those dollars, food sellers have 5, all others have 15, and now I'll make 120 because I can't have a bank with 0 equity. So that's now making sure that the initial conditions for this simulation are correct. And now I'm going to have, say, Aaron buys from food sellers. So I'm now going to use some slightly shorter labels than I used last time around, just gets too bulky. So I'll have Aaron spends on FS. And that's wrong already, because I should have a minus there showing his money coming out of Aaron's account. So I'll do that, minus money coming out of his accounts, which goes into the food sellers' accounts. Okay, then Aaron buys from everybody else, all others. So it's going to be minus, I've got S for spend there. You can use anything you like, of course. There's a label here as long as you're consistent between the rows. So I'm now going to have Aaron underscore S caret, which is uppercase AO, and then have food sellers so that's going to be money coming out of the FS food sellers accounts and being spent on Aaron. And as long as I'm consistent in what I type here, I don't have to put curly brackets around a single character. So you have food sellers spending on Aaron, then food sellers buy from all others. That's just a label, so I can ignore the fact that I haven't been consistent in my cases there. Minus FS, FS underscore S upper, and now I've got to use the brackets AO to make that all others. And then that money turns up, that money turns up in the accounts of all others. And then I'm going to have all others okay, so that's going to be minus AO underscore S for spend, uppercase for Aaron, and then AO underscore S uppercase for Aaron, and then all others buy from food sellers. So it's going to be minus AO underscore S for spend, uppercase, and then I've got to have SS inside curly brackets to get everything superscripted properly. Whoops. Okay, now having done that, that's actually defined without actually filling in what the actual terms are, all the financial flows in the model. So just to show you what Minsky's done in the background, and this is not to scare people, it's just to show why it works. Minsky takes all those entries in the double entry table and generates a set of differential equations, which are what you need to simulate processes over time. So those are the equations there. And if you're trying to do this by hand, and particularly it was a very large model, you're almost certain to make a mistake. You're likely to make an entry on one row that you don't repeat properly on another equation's definition. You can't do that with Minsky because Minsky does the double entry bookkeeping check for you and makes sure that all rows sum to zero, and that's the essential check. That's something I have to, of course, acknowledge that I got from sitting in the office next to Godley way back in 2000 when I was writing the first edition of Debunking Economics, and I was on sabbatical leave at the Levy Institute. Sitting in Hyman Minsky's office, I better add. So it was a rather good time in my life. Okay, so I've defined the basic logic there. I was going to save this now. So I'll call this Aaron stage 2 time constants. And now why am I going to use time constants? Well, let's just first of all copy all the stock variables from the Godley table and copy all the flow variables, and you define the flows in terms of the stocks themselves. I'm not going to worry about reserves, so I'll just delete reserves and I'll delete the bank A. I'll bring those in at a later stage. And what I'm trying to do is explain all the Aaron spending and the food seller spending and all other spending in terms of the amount of money that's currently in their bank accounts. You can use that logic as well if you like. For example, people spending on their income, which is different to the amount of money in their bank account, of course. That's all up to you. This is just to demonstrate the basic idea of building a Minsky model. So let's just make this full screen so it's easier to read and bring these over here. Okay. So the amount of money in Aaron's deposit account is going to determine how much he spends on food sellers and how much he spends on all others. Let's just move these down a bit so I can just focus on Aaron's logic here. Okay, and I'm going to use time constants now, and this again is something which a feature of Minsky that only it has in this space, and that is the capacity to use Greek letters. You might remember when I showed time constants here, they show that time constants are usually denoted by the Greek letter T for tau, or tau. And to type that in any other system dynamics program, you've got to type the letters TAU in English. But if I type \TAU, and I'm going to be underscore now and put F for Aaron to food sellers, and then make that a parameter and give it an initial value of 1 with a maximum of 10 and a minimum of maximum of 2 and a minimum of say 0 with a step size of 0.1. What I'm now going to do is divide, not multiply. Which reminds me, I better not make an attempt to divide by 0, had I? So I'll make it 0.1 as my minimum. Divide Aaron's account by that amount to work out how much he spends on food sellers. Now, what does this now signify? Well, now that I'm using time constant, the one signifies 1 year. And what this is saying, and there are other presentations where I show that. I'm just doing this very quickly, so I won't try to explain it here. If Aaron only spent money on the food sellers, and if he spent consistently and had no other inflows coming into his account, then the rate at which he's spending in very initially, and I'll just click the model so it calculates that. Okay, he would spend his entire $90 in 1 year, and if I make this instead 2 years, then he would spend half of it in 1 year. And if I make it 0.5, and that's being showed 5 by 10 to the minus 3, I'm afraid we use scientific notation here, that is 0.5, then he would spend effectively twice his account over 1 year. So it simply says, at what rate is Aaron spending his money, quickly or slowly? If he's spending it quickly, it's a small number. In this case, it's half a year. And saying in half a year, he'd spend all his money. And that's the idea of a time constant. So it makes it easy to understand what these various constants stand for, and therefore easier to interpret the model when you see it laid out, even though it's strange to be using a divide by key and this tau symbol. Sorry, that actually is a tau. I can change. I think you can change the default font. Let's just see. Preferences and font. Let's go for Arial and see. No, it's still not pretty easy to read. Let's just try one then. Options, preferences. Again, this is a feature we've added with the latest version of Minsky. Boom, boom, boom. Let's see. Let's try Broadway. That'd be weird. Kandara is what I use for most of my presentations. So I'll say, now that's better. Okay, now you can actually see that's a tau. Right, okay. Again, these are some of the features we're adding courtesy of the funding from French Provident. Without this, we'd be stuck with a much more primitive version of Minsky. Okay, so there we have Aaron's deposit account divided by his time constant, which is half a year. Means that if he spent only on the food sellers and there were no other inflows into his account, and he did that constantly, and it's not a tapering amount, he would spend $180 in a single year, or $90 in 1/2 year. So that's why it makes more sense to use these time constants. Now I'm going to shut up here and record this at higher speed, because what I want to now do is define all the others in this system. I want to define the time constant for Aaron spending on all others, and the time constant for food sellers and all others on both Aaron and all others and food sellers, and it's just tedious. So I'll record this and do it, put it in double speed, and then we'll have the final video. So, but let's just take a fast look at the equations now, just to show you what's been added. There are the I've now defined Aaron's where's his time constant here. All these are currently all 0. As I add these definitions, Minsky will define these equations properly, and I'll have a full simulatable system. Okay, here we go, trying to do it quickly and shut up in the process. Okay, that's defined the model. Let's just whack some graphs in here now to show how it runs. I'll just tidy up a bit. We have to add a few more controls over how we format and align stuff. We haven't done that yet, but that'll happen in the next few months. I'd like to be able to take this whole band here and right click and choose align left, align right, which you can do in programs like VenSim and VisSim and so on. Not yet with us, but we're getting there. Okay, let's go back to full scale, bring a chart down, and another one over here, and then show the amount. Let's grab the parents deposit account, food sellers deposit account, and all others deposit account, and wire those up. And then look at the flows as well. There are now 6 flows, of course. So a copy of Aaron spending on food sellers, Aaron spending on all others, food sellers spending on Aaron, sellers spending on all others, and then all other spending on Aaron, and all other spending on food sellers. Now I can just select this pair and choose, hang on, flip, turn them around the other way. Oh, only flips one at a time, pardon me. Let's flip them both one at a time, and I can now wire this to the others. Whoops, okay, that's a mistake. I'll just delete that. I'll explain why that is in a moment, just how the graphs work. We're going to make this slightly more cleaner in a moment. But this marker up here, the ones that are on an angle, they set the maximum and minimum for a graph. If you don't provide an actual number, then the graph will expand as the numbers change. If you do, then that sets upper and lower bounds for charts. Each of these 4 inputs here give you a different colour input onto the time plot for this particular graph, and these 2 go back and go on the other side. But you can have it to 8 plots on one graph, which is a bit much actually. But that's what we've done. So I'm just going to right click here and choose, we call this bank accounts. Whoops! Alright, okay, bank accounts. This is over years, and this is in dollars. Whoops. And this one here is spending per year. It's years, and this is, let's say dollars, let's spell it out fully. Okay, and just hit the stop button and run. And we've got a working model. Whoa, now I've done something. Oh, hang on, no, they're all stabilising. Good, okay. I was worried I had an incomplete definition. One way to tell you've got a bad definition is because one of the flows will go crazy. All the stocks will become crazy as well. But obviously they're all correct, they're all stabilising over time, which is necessary. So that is a very rapid demo of how to build a model of monetary flows in Minsky. I'm sure it looks strange to people who have never used a system dynamics program beforehand. Trust me, if you tried to do this in VenSim or VisSim, it would take forever, not forever, but a long time, because what you'd end up with would look like that too. So it may be, again, confusing for the first time users to have to look at something like this and work out what's going on. In fact, the accountants were right. Double entry bookkeeping is a very easy way of displaying what's going on. So here what I have is the spending, Aaron is spending on food sellers. Aaron is spending on all others. Food sellers are spending on Aaron. Food sellers are spending on all others. All others are spending on Aaron, or all others are spending on food sellers. And it's, again, once you've read that, as long as you accept the logic and as long as these tables, you know the rows sum to 0, you know that this is an accurate model so far as it goes of this monetary system. And that's the whole idea of Minsky in the first place, to make sure that it's easy to effectively audit your model and make sure that it makes sense. Okay, I'll save that, and Aaron can get this one and continue playing to give his local futures talk. Thank you all.